All right, so today is January the 5th. We are doing two things today. We are going to finish up the 5.02 notes, and then we also have a review that's due before 11:15 today. That is 5.0102 review. It's a matching review. It's 19 questions, so you need to do that. So what I wanted to do is just take a minute and kind of run through these notes with you. We did finish those halfway. We also have our assessment on the materials, forms, and weld joints, which I will cover with you here in just a minute. The study guide is posted on there as well. So that is something that you want to make sure you look over before class tomorrow, in addition to getting done with this stuff today. So yesterday, just to kind of recap here, the very first thing that you want to do with metal is to identify it. Grinding is the fastest way because a grinder is a power tool. Metal than a 1/4 inch thick, you need to bevel it. Bevel it is when you cut it at an angle, so therefore you can get your welding rod in there, so you can get good penetration. So basically what these next two slides say, they're pretty wordy. This is what you have to remember. So it doesn't matter as far as the spacing goes, as far as the thickness, everything is going to match the size of your welding rod, right? So if you're using a 3/16 rod, it's going to be 3/16 thickness. If you're using a 3/16 rod, it's going to be a 3/16 spacing, right? So on any of these questions or anything that you see, just always pair it up with the diameter of your welding rod. If you do that, you can't go wrong. Okay, this is what a bevel looks like. Just kind of throwing that in there for you. All right, so you can see that it's going to be just offset just a little bit. All right, that's what's going to give you good penetration. And then the first thing you do is make a root pass, and then you come back through and fill it up with these things called stringer beads. So the weld joints is what we went over in class yesterday, in addition to kinds of metal. So a butt joint, just to recap, is two pieces edge to edge. You can see where they've just butt up against each other. A T-weld is any kind of metal placed to where it forms two 90-degree angles. And then look at this right here. All right. And a proper weld, once you actually cut that in half, what you should see is solid metal. Welding is going to make this metal stronger than what it is originally, right? Because it adds more material to it. If you notice, there's no pits, voids, holes. It's just completely solid, right? And that should be your goal when you're actually welding metal together. A lap weld is when two pieces overlap each other. A corner weld is just that. If it forms a 90-degree, it's going to be a corner weld, right? You should get a nice even penetration on the top. Amperage, this is where we left off yesterday. So a couple things going to determine amperage. And that is basically amperage is how hot your rod is getting, right? How much heat you're putting into the metal. So that's going to determine by metal thickness and the size of your electrode. If you have a thicker piece of metal, you're going to need more heat, so your amperage is going to be higher. If you are using a really skinny rod, like a 3/32 rod, then you're going to have to turn your heat down because that rod is smaller, so therefore it can't push as much heat through it. So amperage setting is determined upon metal thickness and electrode size. And if you have an amperage that's too low, because you don't have enough heat, that bead's going to pile up on the top of it, and it's going to be really high with no penetration. And on the flip side of that, if you have too much heat, it's going to burn into your metal. So you're going to get a flat bead with a whole lot of spatter. Okay. Your goal should be a uniform bead where it looks even all the way down your metal. Just to kind of show you here, you can see low, you can see how skinny it is on a actual low, right? You can see how skinny that bead is. And then you can see on the high, you see all these little specks that are around here. Those are your spatter, right? So it's going to throw a lot of spatter, and you can see where it's almost actually burnt into your metal. And then that, right, that bottom one is what you should be going for, right? Uniform bead, nice and even all the way down, right? So cross section of that, you can really see how high the low is and how flat the high is, right? So it kind of gives you a perspective of your anchoring setting. Before you starting, you can either tap on the metal or lightly scratch your rod on that. I'll show you that later this week. If it does stick, the biggest thing to remember is you got to wiggle that electrode from side to side to get that rod free. So the biggest thing is you want to do the constant travel speed all the way down. That's how fast you move down your metal. If you have a constant speed, then you're able to fix how wide or how narrow amperage, right? But you got to have a good even speed all the way down. If you do have some rusty metal or greasy metal and you're not able to clean it, obviously you're going to need a little bit more heat. Once again, arc length, everything is always the same size as the electrode thickness. Okay. And then, as you can see, that is where your rod is too far away. That's where your rod is too close. And that's that nice even distance right there. It's going to give you a nice uniform bead. You want to tilt your electrode rod just a little bit in the angle that you're going, right? One thing, if you go too fast is also going to give you a narrow bead, right? You can see how icky that is. You slow, it looks like it's all piling up on top of you. So you want that hoppy medium right there in the middle. Just to kind of recap, right? That is the rest of the notes. So after you fill those in, you want to do the 5.0102 review that's matching. And then your assessment tomorrow is going to be on the whole metal joints and forms study guide, which is right here. All right. So when you click on that, what you will see is it's kind of like flashcards. I'll get this open for you here. So it's going to show you the joint, and then you can guess what kind of joint it is. Give me just a second here. All right. So flashcards, right? Two pieces end to end. That's a butt joint. They're overlapping, so that's a lap joint. Two 90-degree weld corners. So 290 degrees is a T-weld or T-joint. Right now, you do have two kinds of corners. On this particular one, you can see where you have to weld on the outside of it. So that would be an outside corner. And then your next one is going to be an inside corner. Sorry about that. Forgot to erase my mark, didn't I? So you can see the difference between the two. The other one's going to be an inside quarter and joint because you got to weld on the inside of it. So you got to have an inside and an outside corner joint. The different forms, you can see that's a 90-degree angle. So that's angle iron, flat. You can see it makes like a little channel right here. If you turn it on its side, that will form a C. So that's channel. If it's round and hollow, it's pipe. If it's square and hollow, it's tube. Okay. Round and solid is going to be a rod. And then the last one, last two, this is expanded metal. A lot of times you'll see them on trailer tailgates. And then you can see where it's got all these ridges on here. So that's rebar, right? Rebar is made of a little bit different material than rod, right? So we're going to have that assessment during class tomorrow. So make sure you look over that. All right. If you have any questions, let me know, and I will see you later.